Okay, we've got two more kinds of equations today, the first of which is radical equations. So a radical equation is ones that have the variable underneath a radical sign. Again, just because your equation has a radical number in it doesn't make it a radical equation. But we look at what's being done to the variable. If the variable is underneath the radical, then it's a radical equation. Okay, so solving these equations are much like doing the square root method for quadratic equations. If you have something that's all squared and you want to undo that square, you do the square root of it. So same thing here. If I have something that's a square root and I need to undo it, I can square it. Okay. Now, a couple of things to remember though. We have to square sides, not individual terms. So just like when we were doing the square root method with quadratics, the first step is to isolate the radical part. Everything else needs to be on the other side of the equal sign. Then we're going to square both sides of the equation, not individual terms. Look at this. If this is on, and just to make it easy, let's keep it with numbers. If that's on one side of the equation, and I go through here and I square, right? Then I'm going to get 4 plus 9, or 13. If this is on one side of the equation and I square the entire side instead of individual terms, I get 25, right? If I could do this, I wouldn't have to isolate the radical. I could just go along and square everything, right? So remember, square both sides. You got to put that side in parentheses and square the entire thing, which is going to involve some using that distributive property sometimes. Okay, then if we have another radical in the equation, we square it, we isolate it and do the same thing. In other words, you can only get rid of one radical at a time. You cannot get rid of more than one at a time. Okay, then we'll be left with an equation that doesn't have a radical sign, and we solve that equation. And just like with the rational equations last time, we've got to check our solutions, except this time, instead of just under the radical, in the original equation, because the method of squaring these things sometimes brings up extraneous solutions, right? If we have the square root of 25 and it's not in an equation, then we just say that equals 5. Technically, when we were doing those quadratic equations in the square root method, remember we said, oh, technically we got to put that plus or minus in there when I do a square root, because negative 5 squared is also 25. So when we're involved in squaring an equation, we get these extra plus or minus values that if we just have a radical sign, not in an equation, it's understood to just be the principal root or that positive one. So we are never going to say in these equations that square root of 25 equals negative 5. We're going to say, no, it doesn't. Okay? Okay, so that's the difference. Let me reiterate that one more time. How do you know when it's a plus or minus? Okay? If you are solving an equation and you put the square root in the equation like we do on completing the square, okay, the equation did not have a square root. I put it in to solve the equation, then I got to put a plus or minus. If the equation started out with it, then it's understood to only be the positive value, no plus or minus, right? If the equation starts out with it, then they're saying, oh, that's only going to be the positive root. If I put it in the equation, I got to say, oh, it could have been a plus or a minus meant under that square. Okay, so let's practice that. Okay, so first step, I notice it's a radical equation, so that radical has to be isolated. It just has to be all by itself on one side of the equation. So I could either move this x over and make it negative x, but notice then I'm going to have a negative here and a negative here. So I would get rid of those negatives by dividing by -1, or I could just in one step move the radical over. Doesn't really matter, whichever you prefer. So first step is isolate the radical. Isolate the radical on one side of the equation. Now this is 0, and I have x equals square root of 15 minus 2x. Once you get the radical isolated, square both sides of the equation. Okay, so this just leaves x squared, but here, this square and this square root undo each other, and it just leaves the 15 minus 2x. Now I'm left with a quadratic equation. So let's add 2x to both sides and subtract 15 and try to factor it. So two numbers that multiply to give -15 times 1, or -15, and add to give 2. What is that? +5 and -3. So either x equals -5 or x equals 3. Now, I have to check these answers before I box them. They might both be good. One of them might be good, or neither of them. I don't know. I have to check them both, and I have to check them in the original equation, right? In the original equation. So just to clear that up a little bit. All right. So if I plug a -5 in here, I would have -5 minus the square root of 15 minus 2 times -5. And I want to know if that equals 0. Well, let's see. -5 minus the square root of 15 minus 2 times -5 is +10. So 15 plus 10 equals 0. -5 minus the square root of 25. Does that equal 0? -5 minus 5 is not 0. Don't forget to mark that out. Or on My Lives Plus, you just don't have to include it. But on a paper, you would have to go back and mark that out. Now let's check 3. Okay, so just because -5 didn't work doesn't mean 3 will. It might, I don't know, I got to check. 3 minus the square root of 15 minus 2 times 3. And I want to know if that equals 0. So it's 3 minus the square root of 15 minus 6 equals 0. 15 minus 6 is 9. Whoops. 15 minus 6 is 9. Oh, 3 minus 3 does equal 0. So there's my solution. Okay, let's try it again. Okay, it's a radical equation. To solve a radical equation, I have to isolate the radical. That means I need to add x to both sides. So square root of 2x. I'm going to leave this by itself. So I'm going to add x, and I'm going to subtract 4 from both sides. Okay, now I square both sides, not individual terms, both sides. Okay, now this square and that square root get to undo each other. And here again is another example of that perfect square trinomial. You can make that x minus 4 times x minus 4 and then distribute, but these things are plenty long enough. We're going to see particularly when there's 2 radicals in an equation. So it's nice to learn that shortcut, which is you square the first one, you multiply everything together, so 4x, and double it, -4x, and double it, -8x, and then you square the last one, +16. It's a quadratic equation, so I'm going to set it equal to 0 and try to factor it. That's my first choice. I've got lots of choices for a quadratic equation. X squared minus 10x plus 16. Two numbers that multiply to give 16 and add to give 10 would be -8 and -2. So either x equals 8 or x equals 2. But remember, we have to check them in the original equation. So let's plug in an 8. So I have the square root of 2 times 8 minus 8 plus 4, and I want to know, does that equal 0? So is the square root of 16 minus 8 plus 4 equal to 0? Is 4 minus 8 plus 4 equal to 0? Yes, it is. -8 plus 8, yes, it is. This one works. Let's try the 2. Okay, so is the square root of 2 times 2 minus 2 plus 4, is that equal to 0 also? Let's see. Square root of 4 minus 2 plus 4, does that equal to 0? Is 2 minus 2 plus 4 equals 0? No, it's not. It's just a coincidence that each of these examples had one answer and one that was not an answer. Okay. They could neither be, or they both might be. Okay, 2 radicals in this one. We can only get rid of one at a time. I have to isolate, it doesn't matter which one. I'm going to leave this one by itself just so it'll be positive, right? But it doesn't matter which one. Let's add the square root of x plus 1 to both sides, so that we have the square root of 2x plus 3 equals 1 plus the square root of x plus 1. Now, we square both sides, not individual terms, both sides. So this is fine over here. That undoes the square root and just leaves 2x plus 3. But here's another good reason for us to know how to multiply out those perfect square trinomials. Oh, I could still do my FOIL and my distributive property, but a lot of times people are confused on what to do with this when I'm multiplying it. So if I use the shortcut, it kind of helps me with that. So you square the first term, you multiply the 2 together, so 1 times that, and double it, so 2 times that. And then you square the second term. Well, if I square this term, that just means that goes away. So I wind up with plus x plus 1 without the radical because I've squared that. Okay, my radical didn't go away. If it did, I'd know something was wrong. You can only get rid of one at a time. So that means I got to move everything over here. Isolate that radical. So I'm going to subtract 1. Okay, so that's gone. I'm going to subtract x so that that's gone, and subtract 1 again so that that's gone. This gives me x. 3 minus 1 is 2 minus 1 equals 2 times the square root of x plus 1. Now this is one term. It's hooked together with multiplication. That's one term. So this radical term is all by itself. So now we square both sides, not individual terms, both sides. Okay, that means, here we go again, square the first one, multiply the 2 terms together, -1x, and double it, and square the last one. Now here, when it's a multiplication, I just square each one. So 2 times 2 is 4, because that's squared, not because it's 2 times 2, it's because it's 2 squared. And then a square and a square root gets to cancel. Okay, so let's get rid of those parentheses then. I have a quadratic equation, so I'm going to set it equal to 0 and try to factor it. So I have x squared. Subtract 4x from both sides will give minus 6x. Subtract 4 from both sides will give minus 3. And I notice it doesn't factor. There's not two numbers that multiply to give negative 3 and add to give negative 6. Okay, I'm going to complete the square. You could quadratic formula if you want, but completing the square would be way easier. Move the constant to the other side of the equation. Okay, take half of 6, which is 3, and square it. Let's add that to both sides. Okay, now this will factor. Let me go back to my original green. This will factor. It's a perfect square trinomial. I know exactly how. Use this sign and that half of number. All squared equals 12. Okay, square root both sides. Use that square root method. Now I put the square root in. I put the square root in this problem, so I do have to say it's plus or minus. And square root of 12, I'm going to make 4 times 3, so that finally I have x minus 3 equals plus or minus 2 square roots of 3. Solve for that x. There's my two solutions. Okay, I got to check them. And this original equation, since we're running out of space, I'm going to erase this. So I'll give you a second if you need, pause your video if you need to right here. And I'll erase this side where we can check our answers. All right. Let's check the plus first. So if we have the square root of 2 times 3 plus 2 square roots of 3 plus 3 minus, I hope I even have room to check this, 3 plus 2 square roots of 3 plus 1 equals 1. Okay, let's see what we have. So let's get rid of those parentheses. So we have 6 plus 4 square roots of 3 plus 3. Don't forget that that's all under that radical. Okay, minus 4 plus 2 square roots of 3. 4 plus 2 square roots of 3 equals 1. So now we've got 9 plus 4 square roots of 3. Oh. Right, 9 plus 4 square roots of 3 minus 4 plus 2 square roots of 3, and we want to know if that equals 1. All right. Let's see. I wonder why they're giving you one like this to check. I plugged that in my calculator and got like 1.25. All right. Let's see about checking. Oh, all right. And you check the other one the same way. Sorry, I was not meant to erase the whole thing. All right, check the other in the same way. Okay, you know what I'm going to do while we're here and I've erased that? I'm just going to double check our math on that because that's a crazy answer for them to have get. Not that I can't get an answer like that, but one that you can't easily check. So let's double check this and see if I made a mistake. Okay, isolate one side. So let's add square root of x plus 1 to both sides. Okay, let's square both sides. It's good practice anyhow, right? Plus, it's fun. Okay, so this will undo the square root and leave just 2x plus 3. Okay, now let's multiply this out. So we square the first one, multiply everything together and double it. And square the last one. I still have a radical, so I need to isolate it. So I'm going to subtract x from both sides, and I'm going to subtract 2 from both sides, and that leaves my okay. Now I'm going to square both sides again. Okay, and then that means I square the first one, I multiply everything together and double it, and I square the last one. Now over here I can just square each one because it's not a plus in there, it's a multiply. Okay, so getting rid of those parentheses, x squared plus 2x plus 1 equals 4x plus 4. Okay, I did have a mistake, so I'm glad we redid this. Okay, so if I subtract 4 from both sides, I get minus 2x. When last time I had a 6x here, notice, right? So if I subtract 4, it's really minus 2x. If I subtract 4 from here, I'll get a minus 3 equals 0. And now this thing will factor. So if you get a crazy answer, it doesn't mean you can't have a crazy answer, but it might be a good reason to go back and check your math. Okay, so now it'll factor as x minus 3, x plus 1 equals 0. So either x is 3 or negative 1. Now, let's check those babies. All right, so let's do the 3 first. The square root of, now if I plug a 3 in here, I'm out of room, so I'm going to tighten this up a little bit. 2 times 3 is 6 plus 3 is 9. So is the square root of 9 minus the square root of, if I plug a 3 in here, 3 plus 1 is 4, is that equal to 1? Is 3 minus 2 equal 1? Yes. Okay, let's check negative 1. If I plug a negative 1 in here, that's negative 2, right? So 3 minus 2 is the square root of 1 minus negative 1 plus 1 is 0, so minus the square root of 0. Is that 1? Yes, the square root of 1 is 1. So this time they were both valid solutions. So I'm glad we redid that. Yeah, I was concerned about that. Okay, what's your signs, right? Happens to everybody. Okay, so, which means no problem if you make a mistake, right? I mean, you know, a little bit of problem grade-wise if you don't go back and catch it. All right, but that's how we learn. Okay, so now notice these are cube roots. It doesn't matter, it's still a radical, right? It's still a radical. So I still need to isolate one of those radicals. And the only difference is, so I'm going to add this to both sides. The only difference is if you have a higher power, instead of squaring it, you just raise it to whatever that power is. Right? So in this case, because they're cube roots, I'm going to cube both sides. These actually are easier because the only ones they're going to give you are ones where both roots go away. They're not going to expect you to cube a binomial over here, right, at this step in the game anyhow. So they're really easier. The entire radicals will go away in one step on these higher powers. And so we're left with 4x squared minus 4x plus 1 equals x. If I subtract x from both sides, I get 4x squared minus 5x plus 1 equals 0. And trying to factor this, now I don't get my shortcut this time. I need two numbers that multiply to give 4 and add to give negative 5. So this time I can't just write it in my factors. I've got to rewrite my problem and use grouping. So I'm going to do minus 4x minus 1x plus 1 equals 0. Factor out that 4. Factor out that 4x. And that's going to leave x minus 1. Factor out negative 1. And that's going to leave x minus 1. So we have x minus 1 times 4x minus 1 equals 0. Means one of those things at least is 0. So either x is 1 or x is 1/4. And on ones that have odd indices right here, right, that's called the index. If it's odd, you don't have to check your answers. Only when they're even. If it was a 4th degree, I would have to check my answers, just like on the radicals where that's a 2, you know, this means there's a 2 right there. We don't have to write the 2. It's understood to be a 2. Odd ones I don't, because I don't have that problem with distinguishing between positives and negatives like I do on an even exponent. So I can just box my answers. Okay, same thing if you have fractional exponents. Okay, because recall from your previous classes that the square root of x is the same thing as x to the 1/2. Fractional exponents are radicals, right? So if I have something like x to the 1/2, I can just square it if I want to get rid of that, only if I have an equation, right? I can square it if I want to get rid of that, because what do when you have an exponent raised to an exponent? You multiply. 1/2 times 2 is 1. It gets rid of that. So same thing here. You have to isolate This is a radical. A fractional exponent is a radical. So I have to isolate that. And then I'm just going to raise everything instead of to the 3/5 to the 5/3. Right? Raise both sides to the 5/3. Because when I multiply this, I need it to be 1. And 3/5 times 5/3. Right? That'll cancel. That'll cancel. It's 1. So here I have x. Now, though, to figure out how to simplify this, the denominator is your index. Right? The denominator is your index. And the numerator is your exponent. So this is also some prerequisite information you should know, being able to go back and forth from exponential values to radical values. So if you need help with that, also let me know. Okay, now I've got the cube root of 27, which is 3. I don't have to worry about plus or minus 3. And then to the 5th, because it's odd. If it was even, I'd have to put plus or minus, right? So then 3 to the 5th is what? 343? 81, 243? Don't have to check my answer because it's odd. The root is odd. Okay, so here I'm going to raise it to what? You're right, the 3/2. Same thing to both sides, raised to the 3/2 power. Now this will cancel. 2/3 times 3/2 is 1. So we're just left with x minus 4 equals, now if I rewrite this, remember, the 2 goes in here. Okay, so I have x minus 4 equals, the square root of 16, don't forget, is plus or minus 4. Okay, plus or minus 4 cubed. Okay, so now x minus 4 equals plus or minus 64. So we have x equals, let's add 4 to both sides, 4 plus or minus 64. So 4 plus 64 is 68. 4 minus 64 is negative 60. And because this is even, I have to check those. I have to check those because it's even. So let's move over here to check them. Okay, let's do 68 first. Okay, so 68 minus 4 to the 2/3 is that 16. So this is 64 to the 2/3 is that 16. Okay, so remember how to rewrite this. The one that's lower stays lower. That's a good way to remember it. Okay. The cube root of 64 is 4, and 4 squared is 16. This one works. Let's try negative 60. Okay, so negative 60 minus 4 to the 2/3. I want to know if that also equals 16. So this is negative 64 to the 2/3. Is that 16? Well, let's rewrite this. So the negative 64 Cube root of negative 64 is negative 4. Negative 4 squared is still 16. They both work. But I got to check them. If the root part is even. Okay, the next kind of equations we're going to talk about are quadratic in form. Now, with those last two we just did, with the fractional exponents, you might see a similarity here, but there's a way we can distinguish between which is which. So an equation is said to be quadratic in form if it can be written in the generic form of a quadratic equation, right? So it has three terms. A square is the biggest exponent. And then we have this linear term. Okay, we don't always in a regular quadratic, but if it's quadratic in form, we need this linear term. All right, so that means that I could have something even like this. So here's what I want to check to see if it's quadratic in form. Three terms, right? Three terms. And when I have it in descending order, and I look at this middle term, as long as the exponent on it is half of this one, or this one's twice as big as that, however you want to think about it, then hey, it's quadratic in form. Okay, and I'll show you what to do with that. Okay, so let's look at this one. Notice it has fractional exponents, but the difference between it and those last two I did, if this did not have this term, right, if that wasn't there, then I would move this over and I'd raise both of these to the 2/3 power and get rid of those fractions. But if it has two terms over here, I can't do that because I would have an expression like this. When I move this over, I would have x plus 1 to the 1/3 minus 2. And then when I raise that to the 3, what? How am I going to do that? No, can't have it. So that's the difference, right? If you have three terms, forget about these being radicals. If you have two terms, then realize that these are radicals, and I'm going to isolate them, get one on each side of the equation, and get rid of them. Okay, but with three terms, so the two things I always want to check to see if this method will work. Three terms. And if I take this exponent and multiply it by 2, so 1/3 times 2 over 1, since I'm working with fractions, is 2/3. And I get the same thing as what's sitting right there. It's quadratic in form. Okay, I just check those two things. If it's quadratic in form, that means we're going to use something called substitution. I'm always going to take this middle term and I'm going to call it u. So u is x plus 1 to the 1/3. That means if I square this and square that, I get that, right? So u squared is x plus 1 to the 2/3. If this condition holds, that's always going to, whatever this is u, that'll be u squared. Just the variable part. If there was numbers out here, right, numbers out here, that doesn't matter. Just the variable part. Okay, that means I can rewrite this now using the numbers and the u's. So this is u squared. U squared minus u, because that's what we said here. U is this part, which makes u squared this part, minus 2 equals 0. Oh, hey, now it's just a regular quadratic equation. I can just factor it, right? So u minus 2, u plus 1 equals 0. Okay, that means either u is 2 or u is -1. Don't forget, though, our problem doesn't have u in it. If someone gave you this problem to solve in your job and you went back and said, oh, u is 2, they'd be like, what? Okay, so I got to remember to substitute back in. So instead of u here, write x plus 1 to the 1/3 is 2. X plus 1 to the 1/3 is 2. And x plus 1 to the 1/3 is -1 for my other solution. Okay, now I got to solve these for x. Now these are like we were just doing. Oh, well, the reciprocal of 1/3 is 3. So all I need to do is raise both sides to the 3rd power. That means 3 over 1, that this is just 1. And I have x plus 1 equals 2 cubed is 8. So x equals 7, right? Subtract 1. And then on this one, same thing. Oh, same thing. Raise it to the 3rd power, both sides. Got to get that negative in there too. 1/3 times 3 is 1. So you have x plus 1 equals -1 cubed is -1. So if you subtract 1 from both sides, x is -2. Now, because this is the index, right? So the root part is odd, I don't have to check them. I don't have to check. If this had been a 1/2, I'd have to check it. Because a 1/2 and a square root's the same, right? But if it's odd, if it's an odd number in the denominator, which means that's the index is odd, I don't have to check them. All right, let's try that again. Oh, look. Okay, I see 3 terms. Although I've got to set that equal to 0, but still, I do see my 3 terms. That's what I'm looking for, to see if it's quadratic in form. And the reason I'm even looking to see if it's quadratic in form is because, oh my word, my exponents are negative. And in that other one, oh my word, my exponents were fractions, right? So I need some method for that. Let's see if it's quadratic in form. If I multiply this by 2, is it right there? Yes, sir. Those 2 conditions hold. It's quadratic in form. Let's subtract 2 from both sides. Well, first let's go ahead, since those conditions hold, let's do our substitution. Let's let u equal the variable part, right? And so if I were to square this, u squared is x to the -2. See how that's going to work out every single time? Okay, so let's subtract 2, put those as u. So that's really, I'm just going to rewrite that 6u squared, because we know u squared is the same thing as x to the -2, plus u, because u is x to the -1, minus 2 equals 0. All right, let that soak in a minute. Okay, makes sense? And you can do that in any order. You could have moved the 2 over first, if that makes more sense for you. Now I'm going to try to factor this. I need 2 numbers that multiply to give -2. I mean -12, right? -12, and add to give 1. So that's 4 and -3. So I'm going to rewrite my problem because the leading coefficient is not 1. So 6u squared, okay, minus 3u plus 4u minus 2, still the same problem. I just expanded that and rewrote it. But now I can factor it by grouping. So I can factor out a 3u, which leaves 2u minus 1, factor out of 2, which leaves 2u minus 1. So now I can factor out the 2u minus 1, which leaves 3u plus 2. Okay, so one of those has to be 0. That means either u is 1/2 or u is negative 2/3. If you need to write that extra step, that's fine. Extra 2 steps, that's fine. Okay, but just don't forget, I don't care what u is, the problem has x's. So I got to go back. U is really x to the negative 1. So it's really x to the negative 1 that equals 1/2, and x to the negative 1 that equals 2/3. Okay. So now I got to know how to deal with negative exponents also. Remember our goal earlier was we were trying to make this exponent of 1. Same thing. What do you multiply negative 1 by to make it positive 1? Negative 1. So let's raise this to the negative 1 power, and the same thing here to the negative 1 power. That means negative 1 times negative, this is just x. And a negative exponent means reciprocals, right? So how do I do this? I flip it. So 2/1 to the positive 1. So x is 2. Or if I were to do the same thing here and raise it to the negative 1 power, then negative 1 times negative 1. But this doesn't have an exponent to multiply by that negative 1. So how do I get rid of the negative 1? I flip it. I use the reciprocal. 3/2. Technically it would be to the positive 1. But I don't need to write that. Now, these aren't rational. They're negative exponents, right? So I don't have to check those. I had to check those things that had radicals. All right, one more. Okay, all different kinds of examples where this can be used: fraction exponents, negative exponents, or larger exponents, as long as there are 3 terms, and if you double this exponent, multiply it by 2, it's sitting right there. Then you know you can use substitution, which means you're going to let u equal whatever the middle variable part is. Not the numerical part is not included, only the variable part. And so that means u squared will be whatever variable is here. Think about that. X squared squared, oh yeah, x to the 4th. So you can rewrite this problem using just these numbers and use for the variable, so it looks like a regular quadratic equation. 12u squared minus 11u plus 2. And now it looks like a regular quadratic equation, so I can just solve it. 2 numbers that multiply to give 24 and add to give negative 11. Okay, how about negative 8 and negative 3? So 12u squared minus 8u minus 3u plus 2 equals 0. Factor by grouping. Hope by now you're getting good at your factoring. Can factor a 4 out of both of these and a u. That leaves 3u minus 2. All I can factor out here is that minus 1. So that's going to change my signs and leave 3u minus 2 equals 0. Now I can factor out 3u minus 2, which leaves 4u minus 1. So either u is 2/3 or u is 1/4, right? Because one of those has to be 0. So I just set each one to 0 and solve that simple linear equation. But I don't care what u is, right? The question's asking about x. So I've got to go back and replace. u with x squared because that's what our original replacement was. So instead of u is 2/3, x squared is 2/3. Or instead of u is 1/4, x squared is 1/4. Okay, now I don't care what x squared is either, just like I didn't care what u was. So I've got to solve these, but it's easy to do the square root method. Square root, square root. So this will cancel and just leave x equal. Now don't forget, if I put the square root in, that's when I know I got to put plus or minus. If it started out with a square root, no. If I put the square root in, this problem doesn't have a square root in it, plus or minus. So plus or minus 2/3. I can't leave, this is prerequisite knowledge, right? So some of this stuff, if you're rusty with, you might need to brush up on, you can contact me. You can do tutor.com, whatever you need, but we should know that you can't leave fractions underneath radicals. So I'm going to rationalize that denominator. First of all, to do that, I need to separate it. And then I'm going to multiply the numerator and the denominator, just like when we did those complex numbers, right? We got to multiply by the same thing on top and bottom so it doesn't change our value, but so that this becomes rationalized. So then we have x equals plus or minus square root of 6 over square root of 9. And square root of 9 I can actually do. So square root of 6 over 3. All right, same thing here. I need to square root this. Oops, I already used green here. Okay. So square root, just to get the x by itself. That'll undo itself. If I put the square root in, I need that plus or minus. Okay, square root of 1/4. Now on this one, when I separate that, I can do each of those. So I just wind up with the square root of 1 is 1, the square root of 4 is 2. It's already rationalized. And notice, remember when I said when we were doing quadratic equations how you have two solutions, a linear one? I said when we get to things with 4 exponents of 4, you'll have 4. If your biggest exponent is 4, here's 2 answers, and here's 2 more. Now, that's only if your exponents are whole numbers. If they're negative, I can't tell how many answers I'm going to have, or if they're fractions, like those other 2. We're also going to talk about some other methods for solving these higher powered ones with whole numbers, but we'll get to that later. But this one, some of them, if I had more terms, I couldn't use this method. So this is a specific method for equations that have 3 terms, and the exponent in the middle is doubled when you set it right here. Okay. So let me know if you have any questions. Okay, happy to help. Look forward to hearing from you.